Okay, I think we are good to go. People are still joining, but I will take care of this beside the training. Yeah, let's start. Again, welcome to the EclipseStore fundamental training. It's one of 3 trainings in a row. So part 2 and 3 will follow in around 2 and 4 weeks. But yeah, for today, let's talk about the fundamental stuff of EclipseStore. One important thing first, this training will be recorded. And that also means you will get access to that recording afterwards. It will take around 1 week or 1 week and a half till you get the link to the training, because we have to cut it a little bit. And yeah, sometimes it takes a bit longer at the end. Yeah, that's me and my colleague Marcus. He's the CEO of MicroStream. Normally, he prepares the entrance of the training. I would say he does all the theoretical part of EclipseStore. But yeah, he's out of office for today, so I will do this at the beginning directly. Yeah, let me introduce myself a little bit. My name is Kuemmel. I'm senior Java developer, project manager of the MicroStream cluster development. So most of the time, I take care about the cluster itself and all the services around the cluster. And I'm also project manager or involved to some project on Allianz Insurance Company, and also some bigger projects on the Fraport German airport. So yeah, that's me. And on top of that, so I'm sometimes doing some speakings or some at conferences, and so maybe some of you have seen me in the past. Okay, let's have a look to the timetable. So we started at 5 o'clock, and then we go through around 2 hours, I would say. And after that, we do a short break at 6:30 p.m. Central European time. And after that, we do the rest of the training. Lesson 5 is the Q&A. I left enough space for all your questions, and I would say that's one of the most important things. Ask as many questions as you can. We have enough time doing that. Yeah, and yeah, that's it, I would say. Let's go through some further informations. So, as I already said, you will get access to the recordings afterwards. And you will also get access to the code repositories of all the demo projects we're working on that training. As questions, you ask as much as you can. I already said this or mentioned this. These are some links or helpful links for you. Let me directly copy paste this to the chat, so that makes it easier for you to use them. So here they are. Okay, now you should have all the links which are important for the training and after, of course. And there are also a certificate available. So, and again, after 5 or 6 days after the training, you should see the certificate when you log in to http://cloud.microstream.1. There is one section which is called certificate, and the important thing is you have to register with the same email address you took part to the training here. That's important. If you have a second one and it's a different one, then let me know. Just write me a short email. I will take care about that. I will register that certificate on the right email address. So, but normally you should sign up with the same email address you took part at the training here. Okay, so let's go through the topics. What do we want to do? So as I already said, we go through a short EclipseStore introduction, what it is, how it works, what are the big benefits of EclipseStore, why to use it, and so on, all that theoretical part. Then I step in with a quick demonstration, a really easy demonstration of how EclipseStore works. Then we do a step-by-step configuration together. So that this is the first hands-on project I want to do. And then we have to talk about all the CRUD operations, because yeah, we are a database in a way, and then we have to cover the CRUD operations, of course. Then we have to talk about creating proper data models. That's an important part of the training, because EclipseStore is not a relational database or something like that. It's a totally different approach, I would say, how to handle data. And then sometimes it makes sense to talk about what is the best practices handling data or creating a data model. We also have to talk about queries, how to get data out of the storage. And we have to talk about lazy loading. So it's an important part, lazy loading also, because EclipseStore is basically an in-memory storage, but not all of the data could stay in memory for some reasons we talk about later. But yeah, that's why lazy loading is implemented. There is a small functionality which is called the REST interface or the client UI. It's just a small helpful tooling, and I will give you a short introduction to that. And an optional, if we have enough time, if there are not that many questions from your side, at the end, we could talk about the legacy type mapping. And only the easy way of legacy type mapping. It's a huge topic, and mostly legacy type mapping is part of the advanced 1 or 2 training. But we can do a small step in or a lightweight step into that topic. As I said, optional. If we do not have, if we still have enough time doing that, we could talk about what happened if the data is changed. So this is legacy type mapping. Okay, so we don't need this no longer. So, okay, so let's get into. Sorry, I missed you. So, okay, here we are. Okay, so let's start with the theoretical part. EclipseStore, it is a Java native data storage, and as I already said, it's an in-memory database. An in-memory database for your application. Let's summarize this a little bit. So EclipseStore is basically a Java framework. That means you will have some dependencies via Maven. You can add it to your project, and then you create your database inside your current project, I would say. So it's a framework. From the basic thing, it's a from scratch invented object graph serialization. That means it's totally new invented. So we do not use the Java serialization at the end. So it's our own serialization. And that enables us to serialize data to most of the known file systems. For example, the normal hard disk, AWS S3, Kafka, relational databases are also possible. DynamoDB, Redis, and so on. You will be able to serialize your data wherever you want. At the end, it's only a binary blob, I would say. Now it comes the interesting part. You will be able to update the serialized data on the storage partially, and that is one of the special things with EclipseStore. We do not have to write down the data again and again, or the full data again and again. So we are able to update the serialized data partially at the end. Most of the data is kept in memory, of course. That is why our storage solution is that fast. But of course, except the lazy parts of the graph, the lazy parts stays on the hard disk as long as they are needed. There is no data mapping anymore. We do not have mapping annotations or stuff like that. You only need your pure Java POJOs. That's all you need. But I will come to that a little bit later. So, and that's why we most of the time talk about EclipseStore is a native Java native storage technology. And to say it in easy words, Eclipse, you write data to the RAM. You only have to take care about the data within the RAM. And EclipseStore takes care about to keep RAM and the storage or the binary part on the hard disk synchronized. That's what it is. Let's move on. The project was created or invented 2013, a long time ago, as a customer project. So we invented it within a project that we need to have, or where normal relational databases are too slow. So that's why we decided to invent an own storage technology, which is much faster. So it goes production on 2015, and we decided to open it for everyone in 2019. So there was a company founded for that. The project was launched, and in 2021, MicroStream 5. It was the name was MicroStream so far. It becomes open source in 2021. Then we do some integrations, Micronaut, Helidon, and Spring integrations for that. And in 2023, we donated MicroStream to the Eclipse Foundation, and that's why the name was changed from MicroStream to EclipseStore. It's still the same product, but the name has changed because of the donation to the Eclipse Foundation. And MicroStream as a company, so we are the company MicroStream, we are doing all the maintenance stuff, we're providing cluster technology, enterprise feature, and so on. But the project itself, EclipseStore, belongs to the Eclipse Foundation. Okay, what are the benefits of EclipseStore? Why should you use EclipseStore at the end? So the point is, EclipseStore is up to 100 or 1,000 times faster than other database systems. That's, I could say this because I knew it, and in some parts you will understand why it is that fast. First point is, most of the time we are working with in-memory data processing. That means whenever you access the data is in memory, and this is the fastest way working with data, and that's also the reason why it is that fast. But on top of that, there are a lot of in-memory stuff ongoing, so like caching, frameworks, and so on. But the problem is most of the caches are not working on the same object model than Java, for example. That means you always have to convert the data at the end. You have to convert it to objects and so on. And this is also a big issue. So, and that's also why there is no more OR mapping anymore needed. That makes EclipseStore more faster than other technologies. And there, of course, there is no JDBC needed anymore. So that is the reason why. It's so as far as I know, one of the fastest database storage systems on the market. It's much easier to use for all the developers because there is no SQL anymore. Only Java is needed to read the data, to store the data. As I already said, there is no more object relational mapping needed, no more Hibernate. Everything is handled under the hood. So you handle your objects, or you have to handle your objects like you normally do. And you will be able to create a data structure that suits best to your business needs instead of the database needs. So that makes things much easier than before. So you will also save costs on infrastructure and license fees, of course, up to 80%. And you might say, oh, okay, 80%, really, is that the truth? I will show you that a little bit later. So as I said, up to, not everyone will save that much, but you will save a lot on costs on infrastructure and some other fees. It's more resilient, of course, because EclipseStore is specially made for microservice application, or that fits perfectly to microservices, and that gives you tons of more possibility to work with it. So you could create smaller database units, for example, for database sharding, as an example. And that makes your database more scalable. So that means, for example, just one example, what you could do, you could create a storage provider just for your customers and another one for your companies and so on. So that means you could split up your database in different smaller database units, and you could provide data via REST and so on. There are many different possibilities. And I think that makes your infrastructure and your projects are more resilient at the end. Okay, now I already mentioned that you would say marketing, blah, blah, of course. Let's have a look to more details to give you an idea why is that. But before,
Christian?
Yeah.
There was a question in chat. I don't know if you have the chance to see it.
Yeah, of course. You will get the slide deck at the end. So you will get a link also after a few days after the training. So then you will get the slide deck. No more SQL, so reporting tools need to be rewritten. Yes, in a way, I would say yes. If you use SQL for accessing the data via your reporting tool, you have to do it. But on the other hand, you could also provide the data via REST also. Most of the reporting tools using REST interfaces to access the data also. That could be one thing you could use. Many different possibilities, I would say. But yeah, if you use JDBC to access the data, you will have to write it again. Yeah. Can we map EclipseStore objects to JDBC JPA to use existing free tools with those interfaces? I would say basically yes. So it is possible to keep the JDBC or JPA annotations on your objects. EclipseStore will not have a problem with that. If this helps to you, I would not recommend this, but yeah, it's not. There is no JDBC interface anymore that works with EclipseStore. It's a totally different approach of handling the data. But I will give you an idea of how to handle this a little bit later. Okay, so what is the problem with the data storage in Java? I would say there are many or a few, and we have to clarify which problems are the most important ones. And as you see, there are 4 in a row. First of all, the high complexity of a database together with Hibernate, handling all that stuff, the data conversion, OR mapping, and so on. And at the same time, it is a lack of performance doing all the stuff. It's expensive infrastructure is required. I will explain you that a little bit more in detail later on. And yeah, let's jump into the details. So the first question, or a question that I ask always, is why sending data to someone to store it? So it's always the same. So we have, like here, we have a Java process on the left. And to storing data, it sends the data to a relational database or to a node database, whatever. But why is that? What is the big benefit of sending data to someone? Have you an idea why you should do that? Have you ever asked that question? Why to send data through the whole country to store it on a database system? What are the benefits of that system? Yeah, decoupling, maybe. Yeah, okay. So we have to check what is the advantage of that.
Maybe because I have multiple instances of my service running in Kubernetes and want to have one single point where the data is stored.
Okay, yeah, makes sense, maybe. Yeah. So I think that's the same point I mentioned here, providing the same data to someone else. So that means multiple services could access the database, right? So that could be one point of that. But there is another question. Is it best practice accessing one database from multiple different applications? suggest that, or do we not suggest? Do we recommend that accessing from different applications? And mostly not. We do not recommend that because there is no caching is possible anymore. Because especially with Hibernate, you always have to refresh the cache at the end if multiple instances accessing one database. And also different business logic could harm your database. So it's quite difficult to doing that. But this is why you do this all the time, right? So you always connect to the same database with multiple services. I knew that because I did it in the same way. But I would say it's not best practice doing that. Next point could be a central storage unit. I think it's the same in a way, but the problem is if the database server is unavailable, also the 50 applications around will be unavailable. So, and that is a big problem, right? And on the other hand, opening a database system to everyone is a lack of security. So let's say we have multiple fat clients around a database, and you always have to have the database in public access. And most of the time, what happened at the end, you create some REST provider microservices that provides the data via REST at the end to all the consumers around to keep the database within your organization, and then you have only to publish your microservices at the end. So it could be possible that the database is a central storage unit, but if this is the best solution, I don't know. Maybe there are different, more or better solution for that. Or is it because no other solution for storing data persistently in the past? And I think that's one of the biggest things. So when we start with relational databases or databases at all, there were no other solutions on the market or within the programming languages to storing data persistently. So because otherwise the easiest thing would be, why not to store the data directly within the Java process to the hard disk, for example? Why not? Things will be much more easier doing that, because this is exactly what EclipseStore do at the end. So we are storing data directly to the hard disk. And that is also the reason, and there is someone, we had embedded databases. Yeah, of course, you could do this, but at the end, you will suffer from OR mapping again, also with that embedded databases. And that's the next point. We always have incompatible data structures. Each Java object graph is different or incompatible to the data structure of the database itself. The relational database is a structure or data model is not the same like the object model at the end. But why is that? So we always have to do OR mapping, and that takes a lot of performance. Have you ever measured that? How much performance does it take? Around, I would say around, in my experience, around 40 to 60% of, depending on the size of the SQL, I would say. But OR mapping takes a lot of performance at the end. Hibernate is highly complex. OR mapping leads to, especially within growing application, mostly leads to a lack of performance. That's my experience. And the data structure of your project is always tied to the database structure. You have to have a structure that fits to your database instead of fitting to your needs. I will give you an example that's also always interesting. All of you guys are using relational database, right? So then you know you always have to have a primary key and a foreign key within a database, right? So does this primary key, foreign key provides you advantages for you as a developer, for example? Why do we need those primary keys and foreign keys within the database? Every select statement you create or every query you create, you always have to repeat the connection between those tables within your databases. Why do we need those primary keys at all? And the foreign keys for the database itself? I don't know if this makes sense. So there are many disadvantages. On the other hand, when we compare objects and the relational database, so within our object graph, a car consists of tires and motors and chassis and whatever, versus we have each piece of a component or each component in a different endless list. And we always have to query all the stuff together to get one object at the end. And that is a huge incompatible thing. So we should not do this anymore. And it's the same on the NoSQL side. So also the NoSQL databases fits not completely to the object graph. Most of them, okay, let's say this is maybe it's a JSON database, you always have to convert JSON to your object graph. But you see at the end, this is one part which is important, and this is the idea why we invented EclipseStore, to make exact those things much more easier to all of us. And another point is we are all suffering from performance, and you see that on the left side. We have an application server here, and let's say we have 4 to 8 CPUs and 16 gigabytes of RAM on the application server side. For whatever reason, I don't know. And on the other side, we have a database, an Oracle database, or MySQL or PostgreSQL, doesn't matter which one, with 60 CPUs and 64 gigabytes of RAM. So let's say we have terabytes of data, and most of the time, because of the lack of performance, some of you might have some things in between, like Elasticache or Redis or whatever, to provide the data much faster to the application server. And this is an architecture which is quite common, I would say, in the current world. Let's say it like this. And people always ask me, okay, EclipseStore sounds great, it works great, but what about the usage of RAM, for example? It's an in-memory database. Are we able to have such amount of RAM at the end, or could we handle that, the amount of data within the RAM? The point is, and you always have your application server in focus, but you have also have to have your database in focus. That means when we compare it to the right side, so when we put everything together, fast access to the data at the end, in-memory caching within your application, and no database is needed anymore. So then we could have one server with 64 gigabytes of RAM and only 60 CPUs, and it works the same. We do not need all the stuff around that. This makes things much more easier. We have less infrastructure costs at the end, less complexity, less license fees, and also maintenance should be easier than before. Okay, let me just check the question. There are many comments. Security, share with other services. Okay, well, the same service. That's an interesting point. Multiple instances on the same service. Okay, let's talk about this. Embedded databases, we talked about that. That's right. So we do not have to use Hibernate at all. So we could also use straight JDBC or SQL directly to the database. That's possible, of course. When we design database schemas first. Let's talk about this a little bit later, or let's see what we can do at the end. There is one thing with SDS models. We delegate many of the design issues here to the support SQL. Okay, so yeah, I would agree that. So in some parts, there are a lot of tools on the market that that helps you to deal with that system. And don't misunderstand me. So I think it's relational databases are working great, and they did a great job in the last few years. And yeah, everything is based on that, and it's working great. But maybe it makes more sense to have a look to different technologies, and that's why you are here, right? So let's have a look to EclipseStore and what advantages it brings to you. This is what we are here. Okay, so we talked about why microstream, and I tried to give you an idea how it is working. So we have a huge performance, and it saves you money, and it's specially built for Java. That's also one thing which is important. So it's only for Java for the moment, or Kotlin, or Java-based systems. This is one benchmark we did. Just a small example. Normally, I do a real-time benchmark within the training, but it's not up and running for now. So we are currently working on that. Please remind me on the advanced 1 or 2 training to show you that benchmark. Then we could have a look to the Grafana board and Prometheus and so on, and we see the different values compared to EclipseStore. But for the moment, I just have that screenshot here to give you an idea of how fast EclipseStore microstream could be. And this is a comparison. You see the details on the right corner here. It's a 40 CPU, 64 gigabytes of RAM machine, JDK, 12 OpenG9 JVM, Hibernate EH cache, and the PostgreSQL database. And compared to EclipseStore version 1. And this is just a comparison, a single query or a simple query and a complex query with hot cache compared to JPA and microstream. I think that gives you an idea why it is that fast. Of course, it must be fast because it's in memory. But the interesting part is why is there so many difference between with a hot cache between JPA and microstream at the end? It's the all R mapping stuff, which is happening in the background. That's why it takes, I think, 4,000 milliseconds. This is quite a lot. So, but yeah, remind me on the advanced 1 training. I will give you a look to the Grafana board on a running system. Okay, I think that was the vision, the philosophy, creating things that are much more easier. So when we started with EclipseStore, we provided RAD tooling, and it was always a big issue to connect non-Java developers to JDBC and SQL and so on. And that's why we searched for that technology, and that's why we invented EclipseStore. So we talked about the data model, Java classes only. This is exactly what we have here. So there is no database model anymore, which is needed. So you have just to create your Java POJOs. So like here, we have a customer POJO, first name, last name, email, age, and so on. Really straightforward Java POJOs. And these POJOs are exactly what you need at the end. You're just working with that POJOs. No annotations, nothing more. That's it. And I think every one of you is able doing that. So storing data persistently, this is the way how EclipseStore stores the data. You see that here there is one root object, and the root object is the on top object of the storage itself. And at the same time, the entrance point to the graph itself. So whenever you want to access your data, you go through your root object, and the root object could have multiple collections and fields and stuff like that. And the root object is the entrance point. And when you start the storage, you will hand over the root object to the database management system. Let's call it like this. And then that enables you storing things. Storing things means you always have to store explicitly. So that means you change something and you have to call a store method to store your changed elements. Okay, these are all the features we support. Strong consistency, multi-threaded at the end, and so on. But we will have a look more detailed a little bit later. Loading data. So how EclipseStore basically works with when it comes to loading data. On startup of the storage, all the data will be loaded into the RAM, except the lazy elements. But let's talk about that later. So let's say we do not have any lazy elements. So we load the whole data at startup. So it's in memory. And after that, we are able to working on that object graph, I would say. As you can see here, a subgraph will be loaded when you call the get method, for example. And in this situation, you see that here there is one lazy wrapper object, and you call the get method. And you just in that moment, when you call the get method, you will get the normal orders or the normal order object. And that's how it works. So let's have a look later on that. Querying. So it's also one topic I want to talk a little bit later in more detail. We're using the Streams API for searching within your object graph. And I think that's, yeah, most of you are familiar with the Streams API. Shouldn't be a big problem for you. But I want to show you the most important streams and stuff around that also later. So there are many more core features within EclipseStore. We have a storage garbage collector, for example, a class versioning handling. So this is what I already mentioned, the legacy type mapping. So what happened if some POJO classes are changing and so on. This is handled by the class version handling. We take care about backupping system. We have some smaller REST interfaces just for development purposes, not for production purposes. And especially that storage browser connects to that REST interfaces. It's high configurable, especially the object graph itself with a high quality API. It's quite simple to use. And let's have a look at this later. All the things and all the frameworks could be used. So we support GraphQL, Lucene, and OpenGenine, whatever you want to have on your project, because we are just using the POJO standard, and that's why we have this. Any JVM technology, so that's what I'm talked about. So Java, GraalVM, Quarkus, Kotlin, Scala. All these technologies are able to use EclipseStore, also Android, instead of, for example, SQLite or stuff like that. You could use and runs wherever Java runs. So that's for sure. So desktop, on-premise, cloud, whatever, microservices, mobile, GraalVM native. And we're supporting JDK 8+. So that's what we do. Nested Java POJOs, objects, and nested collections supported, of course. So yes, there is one root object on top, but you could have, multiple nested objects, collections, whatever. A normal Java object graph, I would say. But I will get into this also a little bit later. Okay, that's it. That's the theoretical part all over, the idea behind EclipseStore, how fast it is, how easy to use it is. And now we could step in our first project. And as I already mentioned, so normally I use Micronaut just for handling data. Otherwise, I always had to create a UI to show the data or see. So, and that's why I use Micronaut all the time. But I want to start with a small basic example project I created here. And that's a normal Maven project, and if you want, you could code along with me. That's the first hands-on project. Let me just check your questions. There are a lot of questions coming in. So what's your business model? The business model is it's easy to explain. We're doing a lot of projects with services projects, and Yeah, our cluster is an enterprise feature, and it's the same on the new upcoming enterprise service. We provide special collections, doing indexes and so on. Yeah, enterprise services. That's the business model. Okay, let me just check if there is another one. So if you want to code along with me, just feel free to open your IDE, create a normal Java basic Maven project. I did it here. So I added a few classes, but there is not much in it. So there is a main class. It's all commented out. So there are only a few classes you will need. The most important ones for the first example is you need a class which is called My Company. It's still empty. We don't need this class for the start project, but you could create it. The first thing you have to do is go to your POM XML and add these two dependencies. So the first one is the main dependency of EclipseStore. It's storage embedded, version 1.4. This is the current or the latest version of EclipseStore. Some of my projects are not on the latest version, but they are good enough using version 1.3, for example. That's okay. And there is another one which is called storage embedded configuration that enables you to adding extended configuration at the end to the storage. So these two dependencies are the most important one. So that means just create one basic Maven project, go to your POM XML and add these two dependencies at the end. So there is no JIT repository for that project because it's just a small example project. But you will get some more extended projects later on. Okay, there is one domain class. So I created several packages here. One package is the domain package, and one it's called data model. Let's just jump in the domain package. There is one class I created, which is called a customer class, a small example class. No matter how many fields are in it. I added name, mail, first name, and age. That's all I need. It's just an example customer class, a small one. Okay, but before we have to use this customer class, let's go to the main class. And after we added the dependency, there is the first line number 7. It's one of the most important lines of the project. It's the embedded storage manager. And this is what I would call the database management system. So whenever you access your storage, you have to access that storage manager. And this is the easiest way to initialize one of the embedded storage manager. There are multiple configurations possible, but for the moment, this is totally fine, just adding this small line of code to create one storage manager instance. You could, by the way, have multiple storage manager in one project. That's possible. So as I already explained, you will need one root object on top of the storage itself, so as an entry point to the storage. And in this case, just to keep it as simple as possible, I just use a string object. That's all do. This makes not really sense, but just to show you and give you an idea how it basically works, a string is totally enough. Later on, we would have the My Company object instead of the hello world here. But this is exactly the the example which could be found in our documentation. So when we have a look to the documentation itself, you will see that small example here works in the same way. So you see that there is the embedded storage manager, we call the start method, and then we say storage manager set root, and there is also that small string as an example. And at the end, I call the method store root. And so this should give you an idea how it works. So at the end, we call the store root, which is not the best way to store, but in this case, it's totally okay to call the store root method. Sometimes it makes sense to have that. And that's it. So after that, just print out the result. Okay, give it a try, right? So let's start that project. Let's see if it works. I had to do a garbage, maybe an update first. Just a second. So, update project. Okay. I forgot to cancel the application. Okay, but that's okay. So I can stop the application. And now what you should see is when we now refresh on the left here, you see that storage folder here. And this storage folder is created. It's the default storage folder. And this is exactly how the storage looks like at the end. So let me just open show in System Explorer to give you okay, here we are. So this is how the database itself or the part of the binary looks like. It consists, most of the time, it consists of one storage folder. You see there are channels 0. So that means EclipseStore is able to have multiple channels on the hard disk. So that's the reason why we have channel 1, 2, 3, 4, and so on. It always has to be the power of 2. So we could have 1 channel, 2, 4, 8, and so on. And the reason for that is some of you might need multi-threaded writing multi-threaded stuff to your binary part. And it increases, especially for heavy writing stuff. It makes sense having multiple channels at the end. But this is a part for advanced 1 or 2 training. But in that example, we have channel 0, and we have a file which is named persistent type dictionary. And this is a really important file. Let me just open this. And so here we are. This is the persistent type dictionary. That means each object within the storage consists of an object type ID and an object ID itself. And this is the way how EclipseStore identifies the values at the end. And at the end, you should see these data types are all the default data types that are supported by EclipseStore. And you will see that a little bit later when we store the My Company object at the end. Then you will see the My Company at the end of that list. So it's kind of like a mapping file within the storage. So the channel 0 folder is the one which contains the data itself. And there is one transaction file and one channel 0 dot file. And this is the file where the data is stored at the end. And you will see later on much more channel files at the end. But yeah, this is created after starting the application. So when we now disable this one and restart the application again, we will see that when we create the system out, you will see the data is stored at the end, and you should see the hello world again. Okay, so let me just stop the application. Here it is. Here you see this is the hello world at the end. So let me just enable this just to shut Done. Yeah, there is one question. Can the number of channel files be limited to have no more than, say, 4? Yes, of course. That's totally up to you. So you have to, you could, this is a configuration stuff. So let me just check storage manager. Dot. Yeah, I will show you this a little bit later. So it's a configuration part. By default, you will have one channel, and it's totally up to you to create some more channels, but you have to do it manually. So it's not done automatically. It's just your configuration. Okay, so let's make a more extended example. So we will keep the storage manager. So we use that one. So first we create our root object. So that means I use the my company object as root object, as entrance object. Then I create another embedded storage manager. And in this situation, I use an extended constructor of the storage manager, which takes the root object, and I'm also able to add the storage path at the end. So this is the decision I made. Okay, please store it to data instead of use the storage folder. But the my company class is still empty, right? So when we jump into, it's still an empty class. So we need to take care about adding something. So let's create a new list for handling our customers. That means let's choose, let's make a new array list. Oh, so let's say public, let's make a private one. So private array list, and customer, I guess, is the right type. Customer equals a new array list. Okay, so let's do it like this. So we need get and set methods at the end. Okay, so we created our root object. So it contains one array list of customers, and now that enables me to add some customers here. So I initialize some customer objects. So let me just jump into the customer to give you an idea how the customer object looks like. We already seen that name, mail, first name, and age. A really straightforward Java POJO, nothing special in it. And so I initialized 2 customer objects. Then I have to add these objects to my root. So that means my company get customers.add the customers at the end. And now this is the first, and in my opinion, one of the most or often made mistakes at the end when it becomes to store something. You always are used to use the thing that you add to store, right? So when we talk about relational databases, you will add a company or add a customer, whatever, you always store the customer itself. And that is a little bit different within EclipseStore. We always have to store the owner of the object, or let's say the reference holder, I would say. And in our situation here, it's the collection itself. That means let's jump into my company. So this array list here is the reference holder of my customer, of my customers, to be more precisely. So there are multiple customers in it, and the array list itself is the object which holds the references. And that's also the reason why we have to store the array list within the storage. That means when I call the store method, and there is one, So this is what I said. So whenever we want to access the storage itself, we always have to contact the storage manager. And let's call the store method. And then we have to hand over the instance to store at the end. And in our opinion, or in our situation, it's my company.get customers, because this returns the array list at the end. So we have to store the reference holder. And that's it. So that's all we need to do. So we created the customers, we added the customers to the root object, and then we have to store the reference holder within the root object. So, okay, just to answer the question, can I reset the data for test purposes? To reset the data, you want to clear the storage, or just for clearing the storage, just delete the files on your hard disk. So that's a quite easy task to delete. Every time you start the application again, it will be automatically created. You can just delete the files. For clearing data or for reverting data, for transactional behavior, for example, there are mechanics, but this is part of the advanced training for now. But yes, there is. Just have a look to the documentation. Another question, is there a support for multiple processes to access the same storage directly? So this, okay, I understand. This is also a question which is all the time asked. I have to say no for now. So it's not possible to access one storage from multiple JVMs. Only one JVM could access a storage for now. But especially for this situation, we mostly recommend using some microservices as storage or data provider services. And that enables that multiple other consumers could add data or consume data, whatever. So, but just one JVM could access the data, the database itself. Is it possible to have a collection as a root object? That's a good question. I've never done this. I guess, yeah, it is possible for sure. It's possible. I think it's in the same way possible that you could use that string as a root object. So it's possible for sure. But the question is, does it make sense to have only one collection? Maybe yes. It's totally up to you. Yeah, but you could use a collection. Maybe that makes sense, especially when we talk about the GigaMap. So we are working on a special collection, which is an enterprise feature at the end, and it's called GigaMap. And I would say maybe with that GigaMap, it could make sense using just that instance of that GigaMap as root object. Could make sense, yes. Could I also store just company? Do you mean this one? Like this, right? So this is what you could do this, just store company, but company itself is not the reference holder of the collection itself. You always have to consider that we only storing the reference holder, and we do not store traversingly. So that means we do not store the whole tree at once. So there are some functionality in place to doing that, but when you store company, nothing has changed within the company object. So when we have a short look to the company object itself, my company here, of course we added something to the array list here, but we did not change something within the company itself. So you could call the store method here, but that would not store the customers within that collection. You have to store the collection because the collection itself is the reference holder of these two instances of a customer or of these customers. So that's important to know. You always have to store the right. There are some possibilities. Just to give you a short idea, storage manager dot create an eager storer, for example. This is an extended way to store things, and this eager storer is able to storing things traversingly. That means when you start on the upper object, it will store everything below. And with that functionality, this will work. So when you use that eager storer, but this is an extended way, and it's, I would say, not the recommended way doing that. It's possible, but for this example here, you should use it this way. Just store the reference holder itself, and it's, in this case, it's the collection itself. Okay. Some more questions maybe. Why store only the customer list instead the company? Okay, I hope I explained this a little bit, because so you have to imagine the way how we handle the data in the background. So when we call a store method, EclipseStore always appends the values at the end of the binary file. So that means every store call appends. It's always appending. So that means the channel file increases more and more during working on with EclipseStore. And that means we have to ensure that the packages which are added to the end of the keep it as small as possible. And therefore, we recommend doing the lazy storing way. And the lazy is the default way how to store stuff. So when we call store here, we call it the lazy storer. It only stores the object or the reference holder which is a part of here. So that means when we call a store, only this collection will be stored, and not all the objects below, because that could lead to a huge amount of objects at the end. So let's say we would call something like store, and then we say root, for example, or in our case, my company is the root, right? So but the root could have millions of sub entities. And this is why it could be dangerous storing the upper object at the end. So based on that, nothing will happen, because it will only store the root object itself and not all the sub elements of the root. Therefore, you have to use the eager storer. But this is quite heavyweight to use this. So use it in a lightweight version just to append smaller parts. We use the lazy storer at the end, and therefore it's important to hand over the reference holder. Hope that answers it a little bit. I think it's the same question. When stored POJO instance, will all nested objects and collection be physically written to the disk even if it's not changed? No, it's not. Only the changed objects will be appended to the end. So let's say when we store the collection here, some of you might say, okay, does it save all the elements of an existing collection will also be stored again? This is not the case. We only store the new ones, and the others, there is only a few IDs that are stored at the end. Okay, give it a try, I would say. So that's it. So everything it seems good. So we will not need this. So let's start that project. Okay, now it's shut down. That's great. So let's check. You see the data folder here? It consists of the same. I already explained things here. Channel 0, persisted type dictionary, everything is the same like before. And now we do not longer need these two elements. This is also not needed anymore. The store is not needed. We only need the last few lines here. So that means we have to initialize the storage manager. We need the my company object as a root object. and then we stream through the collection and just print out the mail. Okay, so that's it. Let's start it. And at the end, we should see the two elements we have stored before. See that? johndoe@example.com and c.kuemmel@microstream.1. So as expected. Yes, it is. So the you mentioned the GigaMap collection is enterprise feature. It's a commercial subscription. Yes, it is. It's on beta now, so we will release it as a beta feature within the next 1 or 2 weeks. So you will be able to try it out for a specific time range, but then you have to pay a subscription for that. Yeah. Okay. So some more questions. So this is the basic functionality of EclipseStore. So we always need the storage manager. We need that start. And we will do step by step some more advanced examples of using the storage. But this is just a small basic example to give you an idea how it basically works. Some more questions from your side. Let me just double check if there are some question I did not recognize. So there was one question: is it in the same process as main Java or separate independent EclipseStore process? So storing the data is a separated process in the background. It's not but the store here, especially this one, this is a blocking statement. So at line 29, when you call this, this is a blocking. You could do this, of course, you could do this of your own within a separated thread to make it non-blockable, but on the normal API, it's a blocking statement. What about if now you delete the customer list in the company class? The customers are deleted when you start. Exactly. So this is exactly what will happen. So we could give it a try. So when I go to my company and I delete these elements here, and let me start. I have to, yeah, it's, but no problem. So let's start this. So the application will start. So you see there are no errors at all. This is because of the legacy type mapping. It's kind of like a versioning. So that's also a question: what happened if something changed within my classes? EclipseStore will do the changes or will handling the changes of a POJO automatically, mostly automatically. There is an heuristic running in the background, and it recognized that something was removed. In our case, the collection itself. And that means that the storage says, okay, it's removed. It's no longer needed. So everything is fine. We could have a short look to the type dictionary. That would be this would be interesting. I promised you that after starting this. So these are all the data types. And now you see this is the my company object. So, and that's the interesting part. So you see that this was the first start of the project itself. And here you could see the domain.myCompany class contains the Java util array list domain myCompany, and the type was customers, or the name was customers. And that was the first start of the application. And the last start, after I deleted it, you see here is another my company class, which with a different object type ID. Here in that case, it's 75, and here we have 72. And this is exactly how the legacy type mapping works. EclipseStore works like automatic versioning. There is a versioning functionality within the storage itself. That means, let's say you have 1 million objects of a customer within your storage, and you remove one field of that customer. You do not have to go through all the values within your storage. It will be changed when you touch one object. It will be automatically changed to the new version, but all the others stays the same before. So, and this is the storage works. It's kind of like a versioning that works in the background. So, and this is also the reason why there are two company objects here available: 175, 172, with different setups. So that means that the customers itself stays in your storage as long as you touch it, or as long when the garbage collection is running, it will delete your customers out of the storage. And on the same time, you see that there is this is our customer element with name, mail, first name, and age with the object type 73. So it's not what you specifically need to know, but I think it's interesting to see how it works in the background. Okay, so another question. When I start this application over and over again, it adds 2 customers each time, even I have equals and hash code saying it is the same. Yes, exactly. That is what Java normally do, because it's an array list, and an array list could have multiple objects with the same instance. An array list is not, it does not check for duplicates.
So the objects have the same ID then, yeah? The same customer with the same ID?
It's just a reference. It's just a reference to the same object. Yes, it is.
Great.
That's exactly, we could have things like that, for example. So what if we would have more than one array list of customers, for example? So it doesn't matter, even if the values or the entities are the same within those collections, they are still referenced. That means it does not doubles the amount of RAM what we need. So it's there are just references. It increases the amount of RAM need, of course, because of the reference itself, but not the object itself. So we are working with references, and that's why it is. Okay, hopefully that answers the question. Do you have a browser of stored data like an IDE plugin or separate admin application? Yes, we do. So there is a REST endpoint. I will come to that a little bit later. So it's not what you might expect, but I give you an idea how to work with that. But how do you access the old items object after modification if you now have only one code object which has a different structure? I'm afraid this is not possible anymore. So let's give it a try. So that means we removed the list here, then we started the application again, and now let's see what happened if we start the application again. Will the data be there again? I'm not sure. I guess not. So because this is let me just check. Do we see it? Is that a new one? Yeah, you will see the data again. Yeah, that's why. But this is yeah, this is kind of like that feels like a hack, because the reason for that is the application itself does not run long enough that the garbage collector could delete the informations here, and that's why we see the data again. But if the application runs all the time, the garbage collection will remove the data at the end. So, but this is not, yeah, that feels like a hack, I would say. because normally the data is gone. We should not do this. That was just a test to see how it reacts when we delete the array list at the end. Okay. I just don't quite understand the versioning aspect. So let's say you have 10 customers, right, within your storage, and let's say it's a customer object like this. So it consists of a name, mail, age, and first name. So, and when we remove age, for example, EclipseStore recognizes this and creates another data type, which is also called customer, but with a different type ID. So that means whenever you access, so let's say you start your application and you access your customers, and let's say you iterate through your customers, whenever you touch an old customer with an object ID 74, let's say, it will be automatically transformed to the newer one. That means the age will be removed and the data is gone at the end. So this is the way how it works. In our example here, we removed the array list, right? So a new my company object is created with a different type ID. And then we reverted the change. So that means we created the same object again. And EclipseStore thought, okay, it's a type like 75 with a type ID 75, and the data is still there because the garbage collection in the background is not running this time. So we did not stream through the data. We just started it, but that's all we did. So the garbage collector itself did not clear the data at the end. Yes, there is a way to force the garbage collector. Yes, it is. But normally there is one method within the API you could force to delete them, but that's it. You will not need this. So sometimes it makes sense, especially when, let's say, when you delete a huge amount of data, for example, and you want to decrease your storage for whatever reason. Then you could force it to delete it now, and then your storage is small again. You will find those methods within the documentation of EclipseStore. Yeah, maybe in the shutdown hook. Yeah, not sure if this is a good way doing that, because sometimes the garbage collection needs more time to run. And yeah, as I said, in a lot of projects I know we did not use to force the garbage collection. It works in the background and it works great. So I would say for now, yeah, you don't have to force it. So. Do you have a preferred workload, like more reads than writes is preferable, or compete better with other projects in the market? No, I would say no. There are no preferred workloads. Of course, so when you write data, you always have to take care about the amount of RAM you have. Of course, you could store 70 millions or terabytes of data if you have enough RAM. That's totally okay. No, it's not a big deal doing that. Sometimes when you really want to have heavy writing stuff, then you have to deal with different structures. I will explain that a little bit later. But yeah, there is no preferred workload, I would say. It's totally up to you. So yeah. Okay, so that was that was the first basic introduction. If there are no more questions, I would go to a further project, a little bit more extended project. And it's the step-by-step configuration. So, and this is the first, I would say, most important hands-on project. it's a Micronaut project itself. So let me share the link to my GitHub that enables you to code along with me. So just a second. So this is the link to the repository. Step-by-step configuration. The project itself consists of multiple branches. And I would say the first branch, or the first important branch, is the beginning branch. We will start on that. And you could stay on the beginning branch. You don't have to switch. But I will switch again and again and again, but you could stay on the beginning branch and type your stuff in it. And if there is something wrong, or you could not keep on track, just switch to the next branch, and you could work on that. So just check it out. So as I already said, it's a Micronaut project. And the only thing you have to do is, especially with dealing with Micronaut, you have to enable your annotation processing of your IDE. It's most of the time it is a setting within your Maven settings. So just go to your preferences. I could search for annotation processing. Here it is. And it has to be on the experimental or automatically. So it's only important that it is enabled. It must be enabled. I could not. I'm not really sure where the setting is on IntelliJ, for example, because I'm an Eclipse guy. I would say maybe some of you could help to find a setting within IntelliJ to enable this. Annotation processing should be enabled. And now I'm on the step-by-step configuration beginning branch here. And just to ensure that the project is running or is working, you could go to the application Java file and just right-click on within the class and start it as a Java application. And at the end, you should see stuff like this within your console. So check out the project, go to the beginning branch, open the application, a Java file, and just start it as a Java project. And then you should see project is running on localhost 8080. So I will give you 5 more minutes just to prepare that project itself. I will go through all the classes after. So just to give you an idea how it basically works. A project like this is, by the way, a quite good solution for providing data to multiple consumers. This is what I will talk about a little bit earlier. So whenever you want to provide data to someone, or you want to have different or multiple data provider, let's say one data provider for customers, one for companies, one for orders, let's say, create a project for each object or for each, let's say, topic of a specific application, and then you could provide your data to everyone, I would say. One thing I like to mention is the way I initialize the object here within that Micronaut project is not the way like you should do within a Micronaut project, because Micronaut works with different technologies and so on. But I try to keep it as simple as possible because this is not a Micronaut training. It's an EclipseStore training. So that's why I initialized the object in a static way and so on. It's not the way to do within Micronaut, but as I said, it's not a Micronaut training. And I try to keep things as easy as possible. Okay, so again, check out the project on the beginning branch and enable your annotation processing. Again, I will show you this here. Just I have to search for annotation processing. It's part of the Maven settings, and in my situation or in my IDE, it's on experimental, and that's okay. Just apply it, and close, and then you will be able to start it. When you want to start it, just go to the application Java file. It's the file that, and then you could say run as Java application, and you should see the Micronaut screen here in the console. That's it. Okay, so let's move on. Let's have a short look to all the classes within my project. Okay, no, there is no special reason. You could use the newest version of Micronaut. It's totally up to you. I had to update the versions again and again and all the time for all those trainings, and that's quite an effort for all the projects. So the version here is good enough for the training. So that's why I use an older one. It's not a production project, so just to keep it as simple as possible. Okay, so let me just double check if we are. This is not how it should look like. Just a second. Okay, I see. Just a second. I have to clean up the things I. So this one. Let's delete those classes. And it's the same on this, replace with head revision, discard changes. We do not need this anymore. Okay. Okay, now we are good to go. And now it should look like different. Okay, now this is how it should look like on your IDE. So you see there is one application, some packages, controller and domain package, and we will fill this within the next steps. Okay, so let's go on. Let's jump to the POM XML. That's the first thing we need to do. So we have to add the EclipseStore dependencies. You could take the dependencies directly from the documentation here. So we need the storage embedded and the storage embedded configuration. So let me copy this. Here we are, dependencies. Let's add this one. So this is the first dependency we need. And the second one is just a moment. This is the wrong project. Here we are. Nice. There it is. So here we are. This is the configuration. So these two dependencies are necessary for the project itself. Both should have the same. The latest version is 1.4 EclipseStore. And as I said, the one is storage embedded and the other one is storage embedded minus configuration. And that's all we need. Most of the time, you will only need these two dependencies. Totally enough. Okay, let me just double check if everything is good so far. So give me just a second. I have to double check the configuration. Okay, so yeah, we are back on track. So let's create another package, or let's use the main package for this. So let's create the DB file. The Micronaut connection to EclipseStore. There is no connection to EclipseStore. Micronaut is a different company. Micronaut provides a microservices framework, and that's just why I use it. I could also use Helidon or Spring, for example. I like Micronaut a lot because I did a lot of projects with that. No special reasons for using Micronaut. Okay, so we need one class to keep the storage manager instance. So, and for that reason, I create one class, and this class is named DB. And every time we want to access to the storage, we go to that DB class. Therefore, it's a static class. Again, it's not the right way doing this within Micronaut, but just for an example, it's good enough to see that. And in that DB class, I create an instance of my storage. So that means I call public static embedded storage manager, and I call it storage manager. And that's it. Yes, it is, because there is a special microstream implementation or integration for Micronaut, but this is a different one. So that because, yeah, let's say the guys from Micronaut created kind of like a plugin to use a specific or a special implementation of EclipseStore within Micronaut. But this is not part of the training for now. Because I want to share with you all the basic stuff of that. You could use different implementations at the end, but you have to understand how it basically works. So I think that's the reason why there is a microstream module within the Micronaut also. So, but again, I come back to the DB class. We need one storage manager instance, and we need one root instance. And to create a root instance like this, I will create another class here. So, and I will call it data root. Let's call it data root. And this is also, a thing that you decide. A data root could be a synthetical object, which does not belong to your object graph or to your business model. I call it data root because it's the entrant object, and that's all. We used the my company before. It's the same. It's the same, but it could be a business object, but it doesn't have. So, but we need an instance of data root, and therefore I create public static data root. Let's call it root equals new data root. Okay, here we are. Should look like this. I will do all the initialization stuff within a static block, just to ensure every time when we access, or when the first time we access the DB class, the storage manager will be initialized. And within the static class, I'm able to initialize my storage manager. So let's say storage manager equals, and now I use a little bit different way to initialize this concept. I use embedded storage configuration dot builder, and that gives me the possibility to add a lot more configuration to the storage itself, and therefore I use that builder pattern, and that gives me the possibility to say, okay, let's define the storage directory, set storage directory, and I will call it data. And people always ask, what is the best solution storing the data? I would always recommend storing the data directly to the hard disk, because it's the fastest way, especially for lazy data. If you want to load data lazily, it's definitely faster when you load it from your local hard disk or persistent volume, whatever. What about AWS S3, for example? You could do this. You could also store the data on an AWS S3 bucket. That's also possible. But I would say for the data itself, that not really matters, because the data stays in the RAM anyway. So you're always working on your RAM layer. And that's why it's not that important having the data on the hard disk or on an AWS S3 bucket. But when it becomes to loading data lazily, then it takes longer loading that from an S3 bucket, for example. So, and in my experience, I would recommend storing data always to the hard disk or to a persistent volume, and creating the backup on an AWS S3 bucket, for example, or writing the backup to your. So there are two backup functionalities within EclipseStore. One is kind of like a mirror. That means whenever you're writing data to your main storage, a mirror will be written in the background. And this mirror could be on an AWS S3 bucket, for example. And then I would recommend creating a full backup, and that this full backup could also be on a different storage target. It's totally up to you. But the main storage, I would recommend doing this on a persistent volume, on the hard disk, whatever else. Can we store data in memory, not on disk, when persistence not necessary? This is in fact a really great question, because storage, okay, when you don't need it, just use Java as it is. So then you won't need EclipseStore.
We may need,
yeah,
we may need to do something like versioning. So yeah, we have everything like in memory with simple Java classes, but it can be useful to store everything in memory and then load when necessary. Okay. Also, it can be very handy to do integration testing.
Okay.
But integration testing is another question. It can be like optimal, but yeah, it's seems like maybe like a useful to have this possibility.
Yeah, maybe it helps that, as I mentioned it, you could have multiple storage managers on within your project. So that means one could store the data on a persistent volume, for example, but you could also store a different, or you could have a storage manager with different store targets. Maybe that helps. I don't think I get it right. So yeah, just having the data in memory is no problem. So there is a way to, okay, maybe that is what you mean. So when, for example, when you want to say, okay, this is part of the data which should not be persistent. For example, you could use the transient annotation to prevent data from storing. That should be possible. So I will show you this a little bit later. Maybe that helps.
Yeah, just to finalize my question, so you understand it correctly. My idea is to have in-memory database, so we have like a duplicate. Yeah, we have everything in memory with simple Java objects, right? right?
Yeah,
But
right.
but we can keep store in memory database, have a duplication structure, right? And after that, if necessary, we can load it. Right. So if we have something changed in memory with simple, so like a backup, for example, like simple, most simple ways backup. Yeah. So we don't need persistence for this, but very quick and fast response, and we don't need.
Okay, I see. Yeah, I understand. Yeah, that's possible. Of course it is. So that means you most of the time working in memory, but just for backupping purposes, you load the data back to the RAM, right? So this is what you need. You could use for that functionality. You could use the rollback functionality. So maybe that could help. So there is. Give me just a second. It's part of the transaction thing. Transactional behavior. I need to find storing data. So this is the transient field part. So that means that prevents fields for storing that. So you could add that transient thing here, and that prevents the password for storing within your on the persistent. But there is just a second. I need to find where is the transactions stuff. Need to find sometimes legacy type mapping, deleting data. No, it needs to be somewhere up here. Housekeeping. No, it must be here. So transient best practices, deep copy. So give me a few minutes, a little bit later, maybe within the break, I will find the right page within the documentation to show you.
Okay. Yeah. Thank you. Let's go ahead.
Okay. So set storage directory data. Let's add the next. So that's all we need to have, but I want to show you set the amount of channels. That was a question a few minutes before. Set channel count, you see that? And that enables you to add a specific amount of channels. So you could set it to 1 or 2 or so 4. And just keep in mind that it must be a value powered of 2. So as I said, 1, 2, 4, 8, 16, and so on. A sweet spot I would recommend is something between 2 and 4. That is totally okay for most of the applications. If your application is more writing data than reading, it could make sense, especially when you writing huge binary files, for example, images and whatever. Then it could be helpful having more than 4 channels, like 8 or 16. But I think that's a special type of or a special situation. Maybe it makes sense having multiple storage managers at the end. One which is configured in a different way than the others, especially for different type of storages or for different type of data, I would say. But this is the way how to set the channel count at the end. Let's keep it like this. Let's keep it in the code. Based on that configuration now, we are able to create a foundation. There are multiple layers in between, and it's always the same. It's always the same workflow. You have to create a configuration, and based on the configuration, you could create an embedded storage foundation. And based on that foundation, we create the storage manager. Create a storage manager. And within the storage manager itself, we hand over the root object, which is initialized in line 10. And then the important part is we have to start it. So that's important. Without starting the storage, it won't work. So this is also having this builder pattern here is the reason why we added the added this dependency here to the POM XML. So this is part of the configuration, and that enables us. So this is my, I would say this is my my favorite way to initialize the storage manager, that builder pattern. You could also use an XML file. You could initialize via YAML file. You could, there are multiple different ways how to initialize a storage manager. But yeah, I prefer this one. It's a great way of doing that. Okay, so set channel count 4, that's it. DB, okay, that's what we need in that class. So we are good to go here. The data root is already in place, but it's still empty. So nothing there. That's it. So let's move on. So I will jump to the next branch. Okay, so yeah, we need some domain objects. Let's create 2 more classes within the domain package. So there is one class, I call it author. So this will be a book example. So let's create an author class. And let's create another one right away. So let's create a book class. Okay, for the book itself, we only create 2 or 3 fields. First one would be private string ISBN, private string name, and private author. That's it. So the book consists of 3 fields, 2 string ISBN and name fields, and another one which is the author. And I think that answers the question that if we could have embedded sub-objects, of course we could. So this is also a big benefit of EclipseStore. EclipseStore is able to handle circular references, which is great. So yeah, we just need to add some get and set methods. Oh, come on. Sometimes I missed the shortcut for creating the stuff. Here we are. Okay. Get and set methods, that's it. And let's create another constructor. So we use the normal constructor ISBN, name, and author. That's it. Can we use records? Yes, of course, you can. And by the way, this is the recommended way doing this. There is a part on the advanced 1 or 2 training which handles concurrencies or how to handle concurrencies within EclipseStore. And one I would recommend is using records if you are able to use records. So sometimes it doesn't make sense using records, but in some other situation it makes sense. Yes, use records. It's supported by EclipseStore. Okay, so we created a book entity. Let's switch to the author itself. It's really straightforward. The author entity also consists of 3 fields. So private string mail, private string first name, and private string last name. So also that question, why are you using always strings? It's just as it is. These are strings, but you could use any Java supported data type, like I don't know, local date, whatever else. It's totally up to you. Most of the Java internal data types are supported. There are a list within our documentation which one are not supported. There are some really specific ones that are not supported. Just have a look to that list. Okay, let's create get and set methods, and here we are, and we also need another constructor. So, using that fields. Okay. So that means we created our root object, data root. We created two domain classes, author and book. We created the database initializer class. Let's call it like this, the POM XML. And that's it. So let's jump into the data root, because data root is still empty. And now we have to add one collection. So let's say private, let's call it final list, book, let's call it books, equals new array list. And of course, it is the type book. Import book. Yeah, here we are. Some get and set methods. Okay, here we go. So this is what all we need to do. So we created our data model. Our data structure consists of books and authors. We created our database instance within the DB class, and that's it. We are good to go. Another point or another thing we have to create are the controller things now to access the data. So that leads me to the last branch. And let's create one controller class, and I call it a book controller. So let's say new class. Let's call it book controller. So to mark this class as a controller class, we have to add the controller annotation. It's a micronaut annotation. And let's say these endpoints are reachable under the books URL. So that means we have to call localhost 8080/books/ whatever the name of the internet of the interface are. Okay, and let's create one method, public. So the return type is HTTP response of micronaut, HTTP, and let's say string. And let's call it create books. Oh, create books. We have also annotate this one. Let's add, this is a get method. So get, and this get method should be available under the create URL. So I think it's the same here. So normally when we create an interface which creates something, or I would not use a get method, but to keep it as simple as possible and to enable you to call this within your browser without any tools like how to say, what is the any REST tool. I created or I used the get annotation. It's not the right way to do, but keep things easy. So and you will be able to call it at the end. Normally we would do a post or an update or whatever else. So, but not a get. Okay, so this is the endpoint for creating books. Let's do so. We first need some authors, and I will copy paste this to keep it to make it a little bit more faster. And I also will copy the books. No worries. I will also send this to the chat. So just copy paste this from the chat. we need to organize the imports. So what happened here is I create 2 author instances and multiple books. And when we call it, these books should be added to the storage. So, and that brings me to my DB class. Let's say db dot root dot give me the books collection dot add book. I could do the add method or add all. That doesn't matter which one. Let's use the collection utils. I'm not sure if this is the right one. Collection utils set off. Yes. And then we could add book 2, book 3, and book 4. Yeah. One way doing this. Second step is storing the added values or the added entities. We use the store method. And now keep in mind, what exactly do we have to store? So in this specific part, or in this case, we added these entities here to the collection. So that means the collection itself is the reference holder of all these books, and we have to store the collection. That means we have to store db root get books. This is what we have to store. Last but not least, we have to return something. So let's return the HTTP response. And let's return an OK. And let's say books success fully created. Okay, it looks like my Git project now. Hopefully it works the same. So let me summarize that a little bit and check if everything is in place. No, there is no lazy model. So when we store the data itself like this, so we have to differ the thing when we talk about lazy. When we have a short look to my root object, data root here, you see the books are stored the normal way within a normal array list, nothing lazy here. That means whenever we start the application, books will be loaded to the RAM all the time and fully. So that means no lazy here. And when we store it, we use the default store behavior. So we use the store method here, and the default one is always lazy store. That means it only stores the instance which is handover here. There are 2 different ways of, or two different types of lazy. The lazy storing process and the storing lazy thing. That's a little bit different. What is the behavior if I use streams? What do you mean with streams? So the data is in memory. So whenever you stream through a collection, yeah, it works like this. When you use streams with a lazy reference, you first have to call the get method. So let's say the array list is a lazy one, then you have to say db.root get books .get, and this will bring you the object itself. And just right in that moment, when you call the get method, the data will be loaded if it's lazy before. And then you could handle this in the normal way to stream through. Okay, so let's start the application and try it out if this is working like expected. So let me just check if there is a storage already in place. It is, so I deleted it. Okay, let's go. So let's start it, run as Java application. Oh, maybe I had to do a Maven update first. So okay, so let's start, run as Java application. Okay, application is up and running. So let's move to the browser. Let's see, when we call localhost 8080, I guess books was the right one. Is it right? Books. Page not found. Okay, that's normal because there is no thing, but I have to call the books/create, right? So this is, yeah, that works. You see that here. This is the initialization of EclipseStore, and we get the response book successfully created. But there is one thing we missed in that application, so we need to call the books. So this is one endpoint we missed. So we need to add another one. I will share this with you. I will copy paste you this. There is another one. This is the get, to get all the books back. So I copy paste this also to my project, and then I could restart it. Okay. So let me jump back to the browser. So now we should have one to see the books. Here they are. So I already stored them, you remember. So these are all my books with the author and so on. And whenever I call the books/create, so I could call it 1,000 times here, it will be created within the storage. So let's see how many books I created. See, here are all that books within my storage. Are all the same. And when we restart it, whenever you see that, when we let me start the application again. Right in that moment, when we access the DB class to get the books, you will see EclipseStore is initialized at the end and returns the data. So see that when we click on give it the data, so it's initialized, data is loaded to the RAM, and now you see the data here. That's how it works. So this is with that application, you created your first data provider. And yeah, as I already explained, it doesn't matter in what kind of infrastructure you use EclipseStore. You could use it within your application server as storage within your application server. And then you provide your data via your application server to certain clients, whatever. But you could also use it as small, lightweight data provider to split up your big monolithic database, for example, into smaller microservices to provide data, having stateful microservices to provide the data at the end. As I said, 1,000 different possibilities to using EclipseStore, storing data without a database, just with pure Java, I would say. Any questions so far? And one question from Alexander: can audit data like entry, update data be easily added? Is there a trigger which can be used to populate update data when the data is about to store? This is not an embedded feature, but because we focus on storing data and try to manage all the necessary things, handling data, transaction, and so on. The audit thing is a thing on top of that. Yeah. Feel free to use any Java technologies to use that audit or to create those audit functionality, but there is no embedded functionality within the framework. Could be that we will implement stuff like this in the future, just let us know. Please go to GitHub discussions, make the suggestion, and we put it on the feature list. Can we have multiple routes? Yes, basically yes. But to be honest, I never just a second. Could we have multiple routes? No, not multiple routes. I remember there was a version, MicroStream version 3 or 4, and there was that's why I'm a little bit confused for now. There was a version which were possible to have multiple routes, but I think for now, no, it's not possible. The reason is the question is, why do you want to have that? You could have one root object that could have multiple collections and entry object. So for example, when you want to have a client structure, for example, then just add a collection of different clients, and each client contains its data at the end. So yeah, you could have multiple storage managers, and with that you could have multiple routes, but it's not possible to have multiple routes as I know so far. And the question is if it makes sense. So yeah. Okay, some more questions. So if not, I would say we are a little late. So let's have our break now. Okay, another question. Can you add a date field now with auto? Okay, so stuff like this. Let's say private local date. Let's say what it is. Let's call it date, whatever. Equals local date dot now. Like this. So kind of like default values, right? So this is what you need to see. Yeah, that's totally okay. The getter should have now. Does this make sense to? I mean, when I create this one, the get method will always return the now value, but you could change it. Getter should have now. The getter, this one. Well, let me just create one. Just I need to understand the reason for that. Okay, get date. Like this, local date now. Like this. Okay, that will work. So at this point, you will not get the real data here. You will always get the current date, I would say. It's possible, up to you. You could do whatever you want within your Java classes. Okay, so let's move on. I cleaned up things a little bit, and I'd like to share the next project with you. It's not I will not do this as an hands-on project. Just a small question. Is there anyone who tried out the first project before the break? Does it work? Was it okay? So just a small feedback from your side. Any issues so far? Okay, great. Worked fine. I did, but I'm struggling to get create working. Worked fine. Okay, Niels, could you find the reason for that? Okay, I see. Maybe with records it works different a little bit because you're not able to initialize that the easy way, I guess. So, but basically records should work. I have not quite figured out how to set at exports Java based internal misc or unnamed. Okay. Maybe you have to check out our documentation there. I knew there is a small part specific for records. Maybe that helps you a little bit. But this is the only thing I could recommend for now. Okay, great. Yeah, there is another project. Just for give you an idea how the CRUD operation could work. Okay, yeah, you're right. So we use the 4 channels, right, within that project. That's a good point. So let's jump quite fast into it. It was this one, step by step. Yeah, you see here the data folder. This is the folder which was created. And now you see here let's open this in System Explorer. Makes it maybe. So now you see that here. These are the channels what I've talked about. So that means now we are able to write down data in 4 different threads to your hard disk. So that's the way how we prevent the write lock from the operating system. And that's why we have 4 channels now, and each channel consists its own data at the end. And yeah, for sure, writing down data in multiple channels, this will speed up your writing speed, of course, because it's multi-threaded. But you always have to consider that when you have to read the data, that leads you to a lower reading rate, I would say, because you have to collect the data from multiple channels. And this could lead to slower data loading, especially on startup. But and that's what I'm talking about. You always have to find the sweet spot for you. But most of the time, something between 2 and 4 is totally okay. This is how it looks like. So nothing special. So these are those channels to enable you multiple threaded writing down data to the hard disk. Is that okay? Okay, great. Yeah, let's jump back to the CRUD demo. Let me share the link with you first. It's a little bit more extended project. Oh, the wrong one. So again, hopefully, yeah, here is the link. Let's go through that project. Let's see the differences within that project. Okay, first things first thing that is different to all the others is I use the XML way to initialize EclipseStore, and I created a microstream.xml file. That is one way to do it, and it's kind of like a property file, and therefore you have the properties of the storage directory, channel count, everything is the same. And I use that XML file here with the class path resource loader. I think this is not the right way doing this within Micronaut. You could use the YAML file also instead of the XML. But yeah, 1,000 different ways to initialize the storage manager and to hand over all the parameters you need. And yeah, and you see that here, I load the file and then I create the embedded storage manager, the definition of the root file or the instance of the root file, and that's it. A little bit a different way to initialize, I would say. But on the other side, most of the things are quite similar compared to the first project we used. So we have a list of books, that's the same. We have authors here, also the same, except the transient thing here. So you remember, I explained that it's transient means that the alias is not stored because it's a transient field. Not found. Let me just check. Done. Copy. Yes, it should be public. Could you please try again with this? I posted the link again. So maybe, yeah, it seems that something went wrong on copy paste. So sorry for that. Great. Okay, so the book controller, which is the important class I want to go through. Maybe this is just a mockup utils class. Okay, I see. So in that project, I added some JSON files as for mockup data. So there is a book JSON file, and there is an authors JSON file, and there should be books, I guess, around 1,000. Yeah, there are 1,000 books. And let's check how many authors. Yeah, 15 authors. That could be great, a great example to show you how to store more data than just 5 or 6 books. And this data will be loaded when we click on the create books method. But let's talk about this a little bit later. Okay, yeah, otherwise, nothing special within that project. And I think it would be interesting going through the controller because I want to talk about the CRUD, the create, read, update functions, and how to use it. So let's start with the create books. We already used a method like this and also the way how to store the books. We talked about this. Store means the lazy storer. That means only the handover reference will be stored or reference holder. In our case, it's book. It's the same like in the previous project. Create a single one. This is the next. It works totally the same. Nothing special in it. We add the book to a list of books and then we use the store method. That's the same. Get books, already the same. Starts with an A. That's the first one, which is a little bit different. And this is what I will come to that a little bit later. It's the Streams API. I'm pretty sure most of you are quite familiar with the Streams API, but some of you might not. So that's why it's a different topic within the training. So I will jump over that, but just to give you a short idea for now to see how it works to getting a specific amount of books. In that case, getting all the books that starts with an A within the title. So using the Streams API. So that means we go through the collection itself, we call the streams, the stream method, and we say, let's filter it. Get name starts with an A. And after that, we need to collect, and we will get a list at the end. So that's what it is. Next one will be interesting. A clear method. That means all the data will be cleared within the storage, especially here to clear the books. And this is really straightforward. So the first thing we need to do is we have to clear the collection itself. And for that, there is a Java native method, which is clear. So clear removes all the data from a specific collection. And then we have to store it. That's all we have to do, just to clear a collection now and to delete data within a specific collection. That's it. Really, really straightforward, I would say. Update single. That's interesting because it's a little bit different to all the other situation we have. So now we update one field within a specific book. In that case, we find the first book of the list. We get the first book and we set the release date to localDate.now. So that means we change the release date of a specific book. And after that, we have to store the book which has changed. And because the book itself is the reference holder of the release date. So when we jump into the book, you see the release date here is a local date. And it's, yeah, I would say it's a native attribute of the book itself. And that's why we have to, that's the reason why book is the reference holder of the local date. And when we change it, we have to store the book. So this is nothing special. But it's different instead of storing the collection when we add a book or remove a book. Now this is the next thing is more interesting, I would say. Update multi-books. So, and this is the situation sometimes it is interesting to discuss a little bit about that. So we want to update all books that starts with an A. That's what we want to do it here. So one situation could be doing it this way. Let's iterate through the books. Let's first of all filter for the book starts with an A, and then iterate through the books with for each. And then we say, okay, let's b.getPrice and multiply with 0.9. And then we set the price. And after that, we could do it this way. We could say db.store or storage manager.store b, right? This is what we could do. Have you an idea why this is not the best way doing that?
In case of many books starting with an A, that would be a lot of overhead.
Yeah, exactly. Because each book has to be stored by its own or as a single point. And I already mentioned this. This is a blocking operation. So it will decrease the performance of your application a lot. So this is why it is not the best approach doing that. What is another solution could be something like this one. So let me just like that, this one, db.storagemanager.store all. And there are two methods, store all. And it's important to mention that these two methods doing different things. The first one, the upper one, iterates through a collection, which is hand-overed here, and stores the element of the collection. And the other one is, yeah, it's an array, and it stores every object which is hand-overed here. So it worked a little bit different. But in our case, we use the iteration one, and then we say db root.getBooks. So this will work, basically. So this is one solution, I would say. Not the best one, in my opinion, but the point is every book, even if it's not changed, will run through this and store all. It's not the fastest way doing that, but it's possible. So all the references, all the books within the collection will be stored in this part. A little bit more extended way is this one. So we create a lazy storer. So as I already explained, please keep in mind using as often as possible the lazy storer. That's why I create a lazy storer here. And then you could create some of transactional behavior. That means we use ls.storeB. And to be honest, the method name here, store, is a little bit misleading, I would say. ls.store, it's kind of like a register for storing, I would say. You could say, okay, that's the storer. Let's register the changed book. And after that, you could call a ls.commit method. I would say that's the best way doing this. And it gives you, later on, it gives you a possibility to do a rollback mechanism, but this is part of an advanced training. I could do it this, you could do it this way. And I would say this is the best practice way doing this. Just change the book, register this on the lazy storer, and after that you call the lazy ls.commit. And when you call the commit, it will be stored to the hard disk at the end. Questions so far to that? Is that clear for you? Okay. Let me just check. What happened if we do stuff like this? Get author dot set first name. Let's call it Mike, whatever. What do you think? What will happen when we're doing things like this?
This will probably not be persisted.
Okay, you're right. So it will not be persisted because we use the lazy store here, and as I explained, it will only store the upper object, right? So, but you have to be careful. The object within the RAM is changed anyway. So you have to keep in mind that all the authors within the RAM are changed at this moment. So this will lead to, yeah, a horrible situation, I would say, because you changed this and everything seems to be good for you because the data in the RAM has changed and everything looks fine. And many authors now has the first name Mike. But at the moment you restart the application, the data will be reverted, right? So because you changed the data within the RAM, but on startup of the next thing, you will see, oh, okay, something went wrong, some data is missing. This is a topic for an advanced training. So we need to talk about rollback mechanisms and exception handling and so on. But in that situation, the first point is Mike will not be stored, will not be persistent. That's okay. And what do we have to do is to store this. We could change this to EclipseStore, and then it's okay. Then now it will be stored at the end because we're storing things traversingly with the EclipseStore. Just to give you an idea how this works. Okay, let's remove this. Not the best way of doing that. Okay, that's it. That's all the CRUD operations. Create, update, we talked about. You see, this is not really rocket science. We talked about very straightforward, as easy as it can be. So that's it. Any questions? Otherwise I would move on to the next section or topic. Okay, so yeah, let's talk about the data model itself. I prepared a quite small PowerPoint for this. Okay, so let's start this. Okay, proper data model. I think it's important to mention some of the parts of the data model because most of you are used to use data models together with Hibernate or other stuff. And I have to say, data models are sometimes different to the models you created before. And there are some things you have to know. Okay, so let's imagine we are a book selling company with multiple bookstores. We are selling thousands of books a day to our customers. So what most important nodes or / tables do we need and how the relations would look like? So this is, I would say this is quite easy. We have a company, of course. In our case, company could be the root object, right? So because this is only one company. So that means company itself would be the root object. It could also contains company name, yeah, whatever else fields could a company have, yeah. Addresses, so my company has an address, the company has multiple stores, and of course, multiple customers. Each store has multiple books, orders, employees, and an address. And it's the same on the customers. Each customer has its own address. A lot of different things we have to think about, maybe a lot more orders, for example, orders and details, whatever. Each book has an author and so it could look like this. This is nothing special. we have to choose when we think about a data type or a data model. When we have a look to the relational database, it would look like this. So we have several tables within the database. One maybe contains the company informations. Then we have one table with all the books, with one table for authors and stores and stuff like that. For each entity, we would have a table. And on the Hibernate side, we use Hibernate in that case. It would look like this. So we talked about. And this is the famous OR mapping we have to do at the end. And now we choose the best from both sides, I would say. From the relational database side, we choose the tables as collections. So that means in a basic way, we say, okay, let's see, we have 10 tables on the relational database. Then let's create 10 collections in my object data model, right? That could be one solution, but then this is not an object-oriented way of having things. And this is also the reason why I said, okay, table as collections, but half the amount, because there is no table anymore for, let's say, addresses. Yeah, there is no table for addresses anymore, because each author has its own address. It's a primary attribute, I would say. It's the same on the company. Each company has its own address. Each store has its own address. So there is no table or collection anymore which contains all the addresses. That could be possible, that there is an additional collection with all the addresses within your object graph, but this is only if it's needed for your business needs. So let's say you want to show a list of all addresses, for example, and you don't want to collect all the different addresses as sub-items from a company, from books, from authors, and so on. And maybe it makes sense to you to show all the addresses within a list. Then it makes sense to have a list of addresses, but not at all. So, and it's the same on different other nodes, I would say. So that means table as collections, but half the amount. And we choose the relations and the fields and validators from Hibernate. And this creates our data model. Let's create powerful collections, lists, and sets. But to be honest, lists and sets are not the best choice for small amount of elements. A list and a set is okay. I would prefer more maps, for example, hash maps to create your own indexes, for example. Or at the end, the gigamap, for example, could also be a helpful collection at the end. And there are many different things more. So I would recommend build a data model for a cache. So it should look like in a way. Or things you have to consider. You have always to think about, where are all my tables? You need to see, okay, what tables do we need, or what collections do I need? An interesting point is what happens if I delete an object. So let's say, what happened if you, give me just a second. I have to think about the situation. So let's, okay, let's say your books contains the authors, right? So what happened if you sell the last book of a specific author? The result is you will get a list of authors, and the last author will be gone. So the author is no longer available because you sold the last book, and then there is no book anymore available with that specific author, and you will lose that author in a list of authors if you need it. So you know what I mean? So that's always an interesting question. What happened if you delete a specific object? Yeah, it will be gone at the end. So, and all this, what about indices, primary keys, foreign keys? Do we need those indices anymore? Is there anything else than lists and sets? Yeah, of course, there are maps, and sometimes they are quite helpful. What about bidirectionals, for example? We also have these bidirectionals within the Hibernate elements. For example, a book has an author, and the author itself contains a list of books, for example. That's what we talk about when this is what bidirectionals means. Could also be possible within EclipseStore. As I already mentioned, EclipseStore supports cycler references. That's not a big problem. Loading data lazily, we talk about this a little bit later. And what are my business needs? I think that's the most important thing when you think about your object model. What are the needs within my business application? And how much data do we have? That's also quite interesting to see, okay, do we have 1,000 or do we have millions of data? That's these are things you have to consider. Okay, let's move into a small project to give you an idea what I'm talking about. So I created one domain, one entity. It's called book. And give me just a second. I have to. Okay, so let's create the first interesting. Let's call it private string. Let's call it title. That's okay. So many of you would ask, okay, do we need an identifier or a primary key? What about the identifier? How does the database work internally? Well, EclipseStore itself don't care about identifier because EclipseStore uses the Java reference object IDs, and each object has its own unique object ID. So EclipseStore don't care about primary keys and foreign keys. But on the business side, you will need identifiers. And that's why I would say a primary key could be important. The question is a title the best fitting option for an identifier? Maybe not. So a good identifier for a book could be private string, string ISBN, for example. So the ISBN is a unique value. So that means whenever you use or whenever you create entities or domain objects within EclipseStore, you have to take care about finding unique identifiers. That's important. So let's imagine we have an order, for example. What identifier for an order would you choose? It could be an order ID, of course, but what about the details? What is the relation between an order and an order detail? See you. Thank you for joining, Sonia. So in that point, it as I already mentioned, for EclipseStore, it doesn't matter. But to find the right identifier for order and order details, it's easy because there is no identifier needed for a specific detail entity, because each detail entity has its own ID. You see position number 1 or 2 or 3 or whatever. And the positions itself are part of the order element. And that there is no big table which contains all the detail entries of all the orders. And then you have to think about, okay, how to bring both together. In this part of EclipseStore, when you create your object, you don't have to take care about, because the identifier for your details or for your positions, I would say, is the order itself. It's and this is why some people are asking always for indexes, for example. Indexes are important parts also with EclipseStore, but not that important like in a relational database, because there are no indices necessary, because in an object graph, the parent object is most of the time the right index for the sub-entities. You know what I mean? So especially for an order has its own detail or position elements, and you will find the positions going through your order, and then you see the position elements or the order details. But to be honest, sometimes it makes sense to have a technical identifier, and I would recommend using things like this. I always use a UUID. This could be quite helpful. UU, I guess, dot random UUID. So whenever you need no. So dot admist to string. No, there is something wrong. UUID. Okay. Okay, the imports or something is, yeah, I don't care. So, but it should look like this. This could help you to create technical identifiers for whatever reason you need it. But there is no primary key and no foreign key needed for EclipseStore at the end, but you have to take care about business identifiers, I would say. Yeah, it could also be auto-incremented long for sure. Then you have to take care about or increment them. That's at the end, it's up to you. So for me, in my experience, this helps me a lot. Even it creates a long string and it's not that readable in some parts, but it's working. And most of the time I'm using technical or business identifiers like the ISBN that are more readable for users and so on. Okay, so that was the first question. Do we need primary keys, foreign keys, and so on? No, we do not need. Okay, so where do we store those books? Well, that's really straightforward. So we already created this. So my company, let's say this is the book selling company, and then I will create a list of books. We already created stuff like this. This is nothing new, I would say. Yeah, here we are. Okay, so that means within my root object, I could have multiple collections. And I think that's also the reason why there was a question a few minutes ago, having multiple roots. I think that's not necessary to have that, but you could have multiple collections within your root entity. Okay, so a customer root object. Okay, company. Okay, so let's talk about the author. So let's jump back to the book itself and private author. So this is the way I would do this. So that means each book has its own author. That's okay. But what about this one? Okay, so this is what I already explained. What if we delete the last book, for example, of a specific authors, then we will lose that author. Normally, when we want to have a list of all authors, we would stream through all the books and would say, okay, map to author, and we would get a list or a set of all authors at the end. But yeah, as I said, if we delete a specific book with the last author in it, we will lose that author. And to prevent that, it could be necessary to have it here. So to have each book has its own author. And on top of that, I would create another array list, or it could be also a set. It doesn't matter, of author here. And then it's always the question, does that increases the amount of of RAM what we need when we have because it's an in-memory database, does this increase the amount of objects what we have within the RAM? And I would say normally not, because if you create an author here, you will add that author to that list. And then after that, you created it here, you use the same reference of that author, and you could add it to the author here. That means each author within a book is just a reference to one specific data at the end on your RAM. So that means, yes, of course, it increases the amount of RAM a little bit because of the reference itself, but the author itself is only once within your stack or RAM, whatever you would call it. Okay, so that could be possible to having a situation like this. And now that brings me to the next point. What about indices? So let's imagine a situation. We have millions of books here. So, and I think there was one question from your side a few minutes ago. Someone asked how to access lazy stuff. So let's do something like, let's say, okay, we have millions of books. Okay, so we are not able to have these books in memory because of the lack of RAM, whatever else. So then we need to find a solution to say, okay, let's call it lazy. And let me just check how to this one, so it should look like this. Okay, and that should also be, this is a new, sometimes, let me just check, sometimes it, it's not easy to keep all that stuff in mind. So domain, data root, no. Come on, Teams, so switch to change to easy. Okay, here we are. So it should look like this. So okay, so instead of this, let's say book. Okay, so a lazy reference, a lazy collection look like this. That means that on startup of the application, the books stays on the hard disk as long as they are needed. So when we call, so somewhere, let's do it here. Let's say books.get. You see that? At that moment, when we call the get method, you will get all the books from your hard disk. So what do you think? Is that a good solution? Let's keep in mind that we have millions of books here. And now you should see that's a big problem, because at the moment we call that get method, you will get an out of memory error at the end. And we have to prevent this. So, and that leads me to the point I explained a little bit before. Array list is not always a good solution storing things in it. It's good for, let's say, small and medium-sized collections. And I would say for every collection which contains data which is needed anyway. So I will come to that a little bit later. But what else could we do? So have you an idea what we could do instead of using an array list, especially for using indices, for example?
Isn't there something like lazy collections or lazy lists in your project?
It is. But also these lists are, I would recommend these lists for small and medium size, because they are working quite well. But on the reading side, they are a little bit slow, because they are loading just chunks of data and release it automatically. This is a part of the advanced tool. There are some things, but yeah, there is another solution I would prefer more than this. Let me show this to you. We could use lazy. Oh no, we could use a hash map, and as a key we use a string, and as values we use an array list of books. So let's call it books2. Let me equals a new hash map. Okay, but that's not, so it has to look like this. Book, lazy, just to, and here we have lazy. Oh, come on. So that Eclipse here. Is it the same? It is, or it is not. So lazy, and then we have to so lazy and array list of books. Now I'm right. So okay, it should look like this. So this is one situation that could help you a lot. As the string, I would recommend maybe the first 4 letters of the ISBN, for example. And a solution like this will bring you the advantage to, when you search for a specific book, you could first search for the first 3 letters of the ISBN, for example, and then you will get access to a very much smaller collection of books, which can be loaded and can be handled at the end within your RAM. So that is one solution. Another solution could be, instead of using the string ISBN, this could be a solution. Let's have the author as an index of a list of books, for example. This could also be a great solution for, it depends on your business needs. And I think that's exactly the point. And on top of that, we are providing our gigamap at the end. I will not go into details for now because it will become beta in next 2 or 3 weeks. But this will be another great collection which can be used within EclipseStore. But just to give you an idea how the indices part works. So create a hash map, and you could create any indexes or indices you need at the end. Even maybe this could also be a great, you could also add the full ISBN, for example, here within the string, and just have one book here. That's even better, one lazy book. So it looks like this at the end. So like this, and then we do not have an array list at the end, instead of having just one book. Oh, something went wrong. Here we are. So then it looks like this. All these things makes totally sense. And especially when we go to the lazy part of the training within the advanced 1 training, we will have a look to the virtual machine and see how much RAM do we need when we use different types of lazy structures. This will be quite interesting for you. But yeah, for now, it's okay to know, okay, what's possible, because I'm not, when I start with EclipseStore, I was not aware to using a hash map within a data structure, because within Hibernate, you would not use this that often. And that's why it's quite interesting to see what's possible within an object graph. And that's great. So a tree is also supported. Multi-map, not sure. is there a data type which is called multimap? I've never used that before. Or what is a multimap? Is it kind of like a tree, or what is it? Or a map within a map? I used this before, so I used things like this, and then I added. I mean, everything is possible. So, and then you could add a hash map like this in it. So that's also possible. You could do many different structures within your object graph. It's totally up to you and your business needs. At the end, to be honest, it's all about having the data in memory. The in-memory part, sometimes it's a little bit difficult to explain. Some of you might say, what if I have 1 terabyte of data? Is it possible to use EclipseStore with 1 terabyte of data? I mean, the point is, you have to ask yourself, do I really need 1 terabyte of data all the time within high speed available in my application? Is that needed? And the next question is, why not to use different storages? So, you know, in the past, we were used to using 1 database and we put everything in that database, no matter if that database is made for that type of data. Nowadays, it's possible to choose different types of storages for different types of data. So there is data which has to be available within milliseconds, and it should be quite fast. Then EclipseStore is a great technology. Use it for that 20% or 30% of the data. What about images? What about binary data, for example? Well, binary data works great even within EclipseStore in a lazy way. So it's a good point. What about binary data? How to store it? It's kind of like the same. You use a hash map, for example. String is maybe kind of like an index. What type of images in it here, and then you have, instead of a book, you have something like a byte array, for example. Oh, come on, like this. This is how to handle images and blobs, for example, within EclipseStore. But yeah, let me come back to the philosophy of EclipseStore. You have always to keep in mind it's an in-memory database. As long as you have enough RAM, it's okay. You can put everything within EclipseStore with no issues, I would say. But the question is if you really need all that data within the RAM. Another aspect is, what about archiving data? Most of our customers having terabytes of data, and when we ask them, do you really, they say, oh no, this is data from the last 20 years. We already have this in our database. And then we ask that, do you really need it? Kick it out, create an archive of something and tear down your amount of data and just use different storage technologies for different type of data. And especially for archive data, an AWS S3 bucket is much more cheaper than a normal database, let's say an Oracle database, for example. I think it's a different type of philosophy how to store data in the future, using different types of storages. And maybe you might say, okay, EclipseStore is not made for the 20 terabytes data I have, for example. But yes, of course, it's an in-memory database. That's quite, that's normal. So what do you think? What is the biggest EC2 instance you could book from AWS? How much of RAM? What do you think is the biggest one? I'm not really sure, but I read something of 265 or 256 terabytes of RAM. So I think it's huge. There are huge amounts of RAM, especially for SAP HANA, for example, and they provide an insane amount of RAM within terabytes for sure, not only gigabytes of RAM. Or 2 terabytes or stuff like that. It's insane. Yeah, that's the point. So as long as you have enough RAM, you could use EclipseStore. And there is another aspect. Let's say you have 1 terabyte on on the storage side. And I don't know why, but you achieved it to using lazy loading and stuff like that, and you start the application and it runs with 8 GB of RAM. That could be possible. Maybe there are a lot of binary data in it, whatever. You always have to consider the more concurrent user you have on your application server, the more data is loaded anyway. So that is also one thing you always have to consider. It's okay to having stuff in lazy loading, but the more user accessing that data, the more the data, which is normally lazy on the hard disk, will be loaded to the RAM. And with an increasing amount of concurrent users, at the end, you will have the full data within the RAM, no matter if it's lazy or not. So this is also one part you always have to keep in mind. Okay, any questions so far? I always talking that much of strategies and so on, but maybe it's interesting for you. But all these things are things you have to consider when we talk about creating an object structure which fits best to your application. The big problem on EclipseStore and especially on the data structure is there is no, let's say, there is no manual which could guide you to doing things always like this. So you always have to create your own structure for your own needs. There is no guideline doing things. So it's totally up to you, and it's up on your experience creating proper object models. Okay. Any questions from your side? Let me check my lists of topics. So we need to speed up things a little bit. 2 topics are left so far. Let's talk about the Java Streams API. I just want to jump into it, especially for you guys when you are not that familiar with the Streams API. I brought a PowerPoint presentation, just 1 or 2. So yeah, basically when we talk about streams, then we talk about an aggregate operation computes a single value from a collection of values. This could be one definition of a stream. The result could be at the end a primitive value, an object like a customer, a list of customers, or void. So that is basically a stream. On the other hand, a stream is a sequence of data elements supporting sequential and parallel aggregation operations. And I would say in easy words, that's what you read here is the definition of Wikipedia of a stream or whatever else. But in easy words, I would say it's a query language for Java collections. So that is one definition, or it's a modern way to process collections. I think these make it more understandable what a stream is at the end. A stream itself consists mostly of 4 or 5 important parts. The first part is a collection, of course. So we need a collection. We need a stream of things to iterate through, and so we need a collection. Could be list, set, hash map, whatever else. The next one is mostly you would have a condition. So for a specific filter, let's say getting all books starts with an A. You remember that this could be a condition at the end, and a condition is always built with a dot filter method. Sometimes we use a mapping. Sometimes we need a stream deeper into objects. Let's imagine we have, let's say we have books. We stream through books, but at the end we want to have the authors of that book. Then we need, for example, the map method. Or let's say we have customers, and customers contains a list of orders. Then we have to use a flat map. But we will see that later on. So that means whenever we have to map something to a different data type, we will need to use a map. At the end, there is a collector, and the collector defines the data structure of the result. So whenever we call .collect, and then we could say, okay, give me a list or give me a set or whatever else. And of course, we have some further functionality like sorting at the end. When we now combine these, then we have always an order like this. So that means we always start on the collection itself. Then we call the stream method. Then we have to do mapping or conditions and sorting within here. And after that, at the end, we mostly have the collector. And that's always the same. So when we create a stream, we always follow this order. We have the stream itself, the collection, the stream. Maybe we have a mapping. So it could be that a customer has its own orders. Then we would call flat map. And within that flat map, we have to stream through the collection of orders. And that brings me, then we have orders here. And based on that orders, I could create .stream, and then I could add conditions and sortings and so on. So this is a boxed variant of a specific stream. And that's it. And to go through those streams, let me just share a project with you. Here we are. Just a second. Yeah, here we are. Copy. This is the repository, and it contains a project which is called Java 8 Streams. Let me close this. It's no longer needed. Let's save it. Yeah, it's this project over here. And I would say let's go through that project on the branch. Switch to stream_impl_done. So that's the part where everything is done and in place. And let's start on the streams controller. And that streams controller shows some of the basic streaming stuff. It might be interesting for you. And it starts with the in-stream integer streams, for example, integer streams with a range from 5 to 10. And after that, you could go with a for each. I think that's a replacement for loops, I would say. Frank, thank you, having you. Bye-bye. Okay, these are the in streams, really straightforward, nothing special. After that, you will be able to create them for each, but maybe it's nice to know having stuff like this. An array stream, for example, let's imagine we have an array of integer numbers. Then there are some methods, stream.off that numbers, and at the end you will get the possibility to stream through. And as I said, these are streams without a result, so that you iterate through a specific collection and doing things with that elements in it. And it's the same with arrays. It's a different framework, I guess. Arrays.stream and nums, and then you could go with a for each in it. Sometimes this is quite helpful. Let me just have a short look to stay in track with. Okay, and last but not least, we have the normal object streams, and this is which is really straightforward. So, and as I already explained, get books, and then we used a for each at the end. The stream in between is missing in that case because we are able to stream directly through the books. So it's not necessary to have a stream in between. Okay, what are the next? At the end, when we want to have a result at the end, then it's interesting having a collector at the end. And please remember, a collector stays always at the end of a stream. And this is what we have here. So there is an array collector. That means we want to have an array as a result. Let's do it like this. So we have db.root, give me the books, stream through the books. And after that, I call the collector toArray, and it creates a new array of books. And it's the same on the list collector, for example, db root get books dot stream. And now this is the collector part dot collect. Give me a list or return a list of books. And this is quite funny because with that line of code, you will be able to transfer data from a list, for example, to a set. And do you know, some of you, what is the differences between list and set? This is Java basic stuff. Ordering, yes, you are right, ordering, but there is another one, which is, I would say, more important than ordering. Exactly, duplicates. Exactly. So an aggregation option of an SQL, for example, to get unique objects is quite easy, because get books is, as I remember right, it's a list. So this list could contain duplicate entries. But when you call this one, you will get a unique set of elements at the end. So that means we stream through the list, and at the end, you will collect it to a set, and then you will get unique elements. What is the use of 59? We have a list and create the same, or no, there is nothing special in it. You are totally right. That doesn't make really sense, but maybe this get books could be a set. Then yeah, it could be helpful converting that to list. I just want to list that to give you an idea what the collectors are. So there is a collectors to list, and there are, as I see, there are many more, a map, and just to give you an idea, we need a collection, we need a stream, and at the end we need the collector, which makes the decision what is the return value at the end. There is another collector type. When we see that, all these belongs to multiple values, to collections, but there is another one. Two interesting ones are these two. So for example, db root.getBooks stream, and then we have the find any. That means it returns any. So any one of that, maybe the first one, maybe not, just one any object. It doesn't have to be always the same. It's just any, and then get. And we have the same one, find first. And now you might say, okay, what is the differences between find any and find first? Well, there is another functionality which is called parallel stream. And that means that the stream goes through that collection in multiple chunks, I would say. And find any says, okay, give me the first element which is find in any chunk, I don't care. So this is what find any does. And the other one is find first. That means it really finds the first element of that stream. So that means whenever you just need one element, you would use find any, find first. And this returns an optional. That means you always have to call the get. Please do not use get in this way. Normally, this is an optional, and you have to check if that optional really contains a book. Then you should call the get. Otherwise, you would get an exception at the end. Okay. There are a lot of more collectors. Example, this one, a list of pets. and we have stream collect, and then there's a collectors.joining. That means that returns one string. So you see that the return value is a string, and it joins all the value with a comma. And I think it's a great solution. Sometimes this could be quite helpful. Joining values, comma separated in a comma separated way. It's quite easy to use. And there are 1,000 more, just to give you an idea what the collectors are and what the basic structure of a stream is. Okay, so let's move on to map and flat map. So that brings me to the book collection here. Need to find the right. So we have it here. Yeah, these are the two examples of the usage of map and flat map. So let's go through this. So you see, we need to return a list of authors, but to get all these authors, we need to stream through the books, because each author is part of a specific book. That means we have to stream through the books to get the authors out of that. Okay, so that means, okay, we stream through the books, we use the stream keyword, and then we have to use the map functionality. And so that means whenever we have to reference a single value within with a single sub-element of books, for example, then we use the map. And map says, okay, C stands for the book itself. Maybe B makes more sense in this way, but or in that case. But I used C, and then I call C.getAuthor. And that means, okay, at the end, we will get back a list of authors. After that, I call the collect and collectors to list. Yes, you are right. Yeah. Is not as optimal as to list. Okay. That's new to me. Did I miss something? Collectors to list returns a modifiable list, just to list is unmodified. Okay, interesting. So I will take this with me. I need to check that. Thank you. Okay, but for now, just the map is an interesting element. So whenever we want to reference a single value within as a sub-element within an object, we would use map. And on the other side, we have that flat map, and we use flat map always when there are multiple elements. For example, here we want to return a list of addresses, and the author itself has a list of addresses, and we stream through the authors, and we use flat map to reference to the list of addresses. And the important thing is you have to use the stream also here in it, because that enables you to add the filter at the end. So you will be able to filter the addresses as a boxed function within the stream through the authors. Sometimes that's a little bit confusing, but I think when you have a reference list of streams like this, you always could look, how does it work? And yeah, during the time you will see how the streams are working. Okay, I see. I can understand. Yeah. Replacing collectors to list, just to list. Okay, interesting. Thanks. I have to reread this after the training. So okay, so we talked about map and flat map. Let's move on. Map and flat map aggregations, not that really interesting, I would say. I will skip this because sometimes it's more interesting to see the filter options. We have some filters here already. Let's start with filter by title. Like this. So it's always the same structure, stream, and then we add the filter, the condition within here, and then we call the collect equals Bunk of Dangerous, for example, and it's the same here. b.getName starts with an A. It's the same. It's a filter condition in between. And I like this solution much to use predicates instead of using add the filter directly. So that means I create predicates here, and that predicates give me the possibility to combine them. You see that here. There is a name predicate and an ISBN predicate. It's the condition itself. And that enables me to say, okay, let's use the name predicate dot and the ISBN predicate. And now you see that's quite similar to the SQL at the end. And then I could use this predicate as the condition here within that filter. And after that, I call the collector, and that's it. I think that's the way how we query data within EclipseStore. And you see now see why EclipseStore takes that long on the market, because before Java 8 there were no streams within Java, and without a search engine, EclipseStore would not work that much. So we had to create our own streams. But yeah, streams are already in place, working great. So just use it. Let me just check. Sorting, maybe that could be interesting. Sorting, I don't know where it is. Maybe it's not that important. There are 1,000 of different homepages to find some help to those streams. I created some examples as a task for you to do, but I think because of the time we have to skip this. Just have a short look. There are some interesting things in it, like any match, for example, which could be used. Some aggregate functions are already in place. Just a second, where is it? Yeah, here, grouping stuff, for example, or some price reducing, so to summarize prices. Many different possibilities. And yeah, it's always the same. I don't have this in my mind. I always have to look for it when I need it, because this is not needed all the time. So yeah. Okay, any questions? And thanks for the hint of just to list. Makes sense to me, but I have to reread this. Yeah. Okay, this is the way how to query data instead of using SQL. So, and last but not least, let me just check my list of topics. Okay, last but not least, the client UI, the REST interface. And also for this, I prepared a small example project because for the most people, and one of the biggest problem, I would say, in my experience, is a lot of people suffering from not able seeing data within the storage. I don't know why. Now I'm working with EclipseStore for years now, and for me, I don't know, it's normal not seeing the data. And if I need to see the data, I used my own REST interfaces to call the data, and then I'm able to see this, to see the data. But at the beginning, it was the same for me. I always tried to see, okay, is the data there? How it looks like? Could I change the data? What if I need to see the data? And we started to create a client UI. Let's jump into this. And the first thing you have to do is, moment, this is the master. Let me just check if there is another branch. No. Okay. So let's open the DB class. And what you have to do is just initialize your EclipseStore storage as usual. And then you have to enable the REST service. That means you call the service here. You have to call it. And by the way, this is also documented within the EclipseStore documentation. You will also see the code within on our homepage. But you have to start the REST service. And this is only for development purpose. This is not for production, because there is no authentication or stuff like that. This feature is still, I would not say work in progress, but we developed it till a specific point, and now we knew that we have to improve this more and more, but we are not at that point that we have enough time to improve it more and more. But yeah, this is the way how to enable it. And after that, let's start this application. So give me just a second. So application run as Java application. So now I also have to read how to access it, the client UI. Okay, when we now go to the documentation, you will find the REST interface here. This is how to set up it. So this is you have to add an additional part within the POM XML, and then you need to moment, just a second. Okay, this is the documentation client UI. Okay. So then we need to download a small jar file, and I already downloaded it. So, but for the version 1.4, I have to do it again. So it is done. And after that, we start this jar file. Just a second. It's the client UI. So it takes a little bit. Okay. Come on. So the application itself is up and running. So let me just double check if there is still data in it. So localhost 8080 slash, let's try the /books endpoint. Cannot send more than requests. Okay, writing file. Okay. Maybe I have to update projects first. Single get books, yeah, should be the same. And there is data still there. Okay, that was the problem. Okay, application run as Java application. Okay, okay, you see the storage is empty. I got an empty result, and let's call it create. Book successfully created. And when I now call books again, I see all the books within my storage. Okay, during the time the download is finished. So here we have the download. I just go to the to copy this one, call CMD to start it. Okay, and now I have to call the jar file. There we are. Here, what is the okay, here we are. Okay, let's call it. So, and now you will reach that application when you call the local host 888. It looks like this. So you will see that within the browser. So the important thing is you have to ensure that your application is up and running. So like here, because the REST interface needs the application itself, then we have to start a jar file. You will get the application itself, and then you could use this URL. It's always the same URL, and you will be able to change it to connect to your current application. And this is what you will see at the end. That enables you to see, okay, first let's start at the statistics. You see some file count, the live data size, and so on. You see the different channels of the application, the data size, and so on, the channel size. But the most interesting part is the data itself. So, and you see the structure of the elements is different to what you are used to see when we talk about the database itself. But it enables you to see what's going on within. So you see the root itself. It consists of one array list of books, and I'm not sure if. Let me just double check if books in that case is, what structure is it? Data root. Okay, it's a list of books. So, and you see when I go into it, you see this is the index, and that's the book itself. This is how it works for the moment, and that gives you a little bit of the possibility to see what's going on in your application. But to be honest, I've never used that tool, and I did a lot of projects with my colleagues with EclipseStore. It needs a little bit to I don't know the English word for that, to deal with it this way. But you will see after a certain amount of time, you will no longer need this. And yeah, maybe you create your own REST endpoints to see what's going on within the database, or you have a small UI to show the data. It's totally up to you which fits best at the end. Most of the time, we are creating data provider applications, and then you have REST endpoints anyway. And that works great without any client UI. But it's there. As I said, we are still working on this. I'm pretty sure that within the next few months, there will be an update of that to make it more usable, I would say. But for now, it's there. You can use it. And yeah, it's on you to use it this way. Okay, any questions so far? I also could share this project with you, client UI. Give me just a second. Oh. Need to find the right one. Yeah, here it is. This is the link to the URL. Okay, so if there are no questions so far from your side, we are right in time, I would say. When I go through all the topics for today, we did a small introduction, we did a quick demonstration together, we created a step-by-step configuration, we talked about the CRUD operations at the end. I talked a lot about creating a proper data model. Within that topic, I covered also the first step into the lazy loading stuff. And this is what I want to do. So just give you a short idea of how lazy loading works. Basically, there is a more extended version of lazy loading in the advanced 1 topic. And I already told you that that we do a little bit researching on lazy loading, seeing, okay, how big is the data within the RAM and so on within the virtual machine. But yeah, this is part of advanced 1 training. We talked about queries and Java Streams API. And last but not least, I started the client UI for you. Yeah, we're running a little bit out of time, but that's not that big problem because we clarified a lot of your questions, and your questions are more important than the client UI, in my opinion. Optional legacy type mapping, I explained you that a little bit at the beginning. Yeah, I would say we are good so far. If there are no questions so far, this is only UI, how to enable the REST endpoint for this again. Please have a look to the project I shared with you. There is a small 2 lines on the DB class to enable the REST endpoint. Just have a look to the project. And this is also, it's also covered with the documentation. Okay, so yeah, I have to say thank you for joining the fundamentals training. It was a great pleasure for me. I hope it was interesting and you learned a lot, and that helps you to get into EclipseStore. If there are any further questions, feel free to send me an email. So let me just share my email address with you at microstream.one. So if there are any questions, feel free to send me an email. I will do my best to answer it. If the questions are more complex, please go to the GitHub discussion page. Then you will get support there. Yeah. Okay. That's all from my side. Thank you for joining. Hope this was interesting for you, and see you in the advanced 1 training. Have a nice day. Have a nice evening. Thank you and goodbye.